Okay, let's just finish off. Okay, so it's taping again. Okay, so are we all happy with this diagram of how the guard cells open and why they're there?
Yes.
All right. So, as a botanist, you could actually, just like we peeled off the epidermis, off an onion, and what I normally do now is we run downstairs and we fetch leaves and we peel off the epidermis of those long strap-shaped leaves here at the bottom. And we put that under the microscope and you see guard cells, but I don't know if I'm allowed to use up my microscopes now because we're breathing on it, okay? So if you do that, you could see this. All right. Now, these are just photographs, so you must just be able to recognize them. This one's been stained. It looks sort of greeny colored. These are taken with a scanning electron microscope. That's with a light microscope. Do you remember monocots and dicots?
Yes.
So grass leaves. Did anyone go sit on the grass yesterday and look at the veins?
Yes, I did.
And you can see it from the veins are on the inside, but the epidermis, the cells, are also long and thin.
Yeah.
That's how they're arranged. So these are the normal epidermal cells, and these guard cells. Can you see they're closed? Okay. But in a leaf, a dicot leaf, you don't need to know dicots, etc. Okay, the leaves, not only do they have net, N-E-T, like a net venation. If you look at the epidermis, if you could peel it off, you'd see that the normal epidermal cells can have very odd shapes. And you can actually identify species by doing that. So they are the normal epidermal cells, and you can see these guard cells are open. And the same over there. And yeah, you can even see the little chloroplasts. So it's only the guard cells that have chloroplasts. Okay.
Ma'am,
Yeah.
why does it itch when you sit on grass?
I'm just thinking, because they've got all those little hairs.
Yeah.
Yeah. And also maybe when there's the little flowers, those little feathery things, and you're allergic to it, that could be as well. Okay, so that's the end of epidermis. Okay, so page 2 now. At the top it says guard cells.
Yes, we've done.
Okay, so they're bean-shaped epidermal cells that surround the stoma or pore in the epidermis of leaves and young green stems, but not in a woody stem. The epidermis actually breaks off because there's so much bark. And then you've got the picture. Now that picture, sorry, on the video at home I actually showed it, but yeah, that little picture, it looks quite green, doesn't it? But you know what happened there? I should actually take that one out. When they peel this epidermis off the leaf, what it's doing, you can't just peel the epidermis. So when they peel, when they peel this epidermis off the leaf, we actually use nail varnish. We sometimes put clear nail varnish on, and then when it dries, we peel it off. It helps us to take this epidermis off. But sometimes it pulls the cells, the green cells underneath up as well. So that's why the little photograph in the table, if you look at the color version, okay, well, if you look at this little color version there, all right, it looks green, but in fact it's only the guard cells that have got chloroplast. There you're just seeing like shadows of the cells underneath. Okay, so it's actually a good idea to leave this in, because when you look at things under the microscope, it might not always look exactly the same as what you see in the textbook. All right, so that was epidermis. Oh, hang on, function. The guard cells move apart to open the stomata to allow for and transpiration and gaseous exchange. That's it. We're going to finish too quick today.
That's fine.
It's fine. Okay. So what have we got now? We've got the growing tissue of the plant, the meristematic. We've got the outside, like a bag. We've got the epidermis covering the plant. What must we do now?
The inside.
We must fill it up. So the main heading there is ground tissue. That's what he said on the video, Mr. Anderson. It just means the filling up tissue inside the plant. And I know in your textbook, and you might have seen there that I uploaded the textbook as well, because some people have left their stuff here, you know. So go and look, if you're at home and you can't find your textbook, go and look on Google Classroom. Okay, I'm just looking in the book. So there's not much in the textbook, and sometimes it's just lots of writing. So you can go and look there. I'm not going to explain it. You can just go and look there for extra information. And we've only done page 60. So meristematic and then epidermal. And then it jumps, we need to jump here. They've got ground tissue on page 62. And they've given it as a table. And just like Mr. Anderson said, that the soft spongy material, the one that fills up the plant, when you eat an apple or a potato or a pear or a banana, the soft one that packs or fills up the plant is called parenchyma. And then the two strengthening tissues that give a little bit of rigidity to that parenchyma are and sclerenchyma. Parenchyma, sclerenchyma. Collenchyma, sclerenchyma. All right, so those are the tissues that fill up the plant, and then we just have to do vascular. So we're only doing parenchyma now, and when we come back, we'll do the collenchyma, the sclerenchyma, the strengthening tissues, and then the xylem and the phloem. That's a little bit more difficult. Okay, that's the complex tissue, hey, made up of one or two or more types of cells. And there's even a mistake in the textbook, and the textbook that I scanned has corrected the picture on page 62 for sclerenchyma. That ain't sclerenchyma. So it's actually been corrected. All right, but when we get there, I'll show you.
Now, when you say when we come back, are we doing that after midterm?
Yes.
Okay.
Yeah, we're only going to do up to parenchyma this term, isn't it? Okay. All right, so let's have a look.
Then what are we going to do on Friday?
Friday, we're going to mark the worksheet, and I'm going to ask if I can show you microscope slides. I don't know if I can. I'd like to. I even brought stuff with the apple and pears and stuff. Apple and potato. Okay, this is just for interest. So have you ever noticed that some leaves are very hairy?
Yes.
All right, now they're called trichomes, and once again, you can actually identify different species of plants. If you're a trichome specialist, you can figure out which these belong to. Now remember, root hairs are unicellular, but the hairs on leaves, does anyone know what this plant is? There's some next door in the fish tank at the back. You never saw it.
No.
It's like my fish tank there. It's called a terrarium. I water it once or twice a year, that's all. It's a water cycle. So at the back there, I need to go check. Okay, there's an old fish tank with these plants. Haven't you ever bought them? Come on. They're called African violets. Okay, so they've got very hairy leaves. So there's a very hairy leaf. They're maybe not as hairy, but what do you think all those hairs are doing on the leaf? What are they trapping? Water, yeah. So when the plant's transpiring, it keeps the water vapor there so that they don't lose too much. Okay. Didn't we do that when I did xerophytes with you during ecology? And I said plants that live in a desert where there's not much water are xerophytes, and they've got ways to prevent losing too much water.
Oh, yes.
Like a cactus has thorn leaves. Remember that?
I don't remember the word xerophytes, but I know that.
Yeah.
That.
So this is a zero, I'm just saying now, just for interest, it's a xerophytic characteristic, because all those little hairs, if the water vapor comes out, it's going to stay there. It's just like if you are very hairy, keep your warmth there. Okay? Alright, maybe some of the guys, but now we shave it off. Okay, alright, so hairs trap water vapor, keeping you nice and warm. Alright, so here, hairs trap heat on you, but hairs on the leaf would trap water vapor so that they don't transpire too much. It's a protective mechanism. Okay, so a little bit more. Alright, so now I've got this diagram. Okay, so when I showed you the leaf, cross-section through a leaf, so we had upper epidermis, lower epidermis with guard cells, and what's all this green stuff in the middle, filling up the leaf? Parenchyma. But these parenchyma cells, what do they have? Why are they this color?
They have chloroplasts.
Lots of chloroplasts. In fact, the ones near the top have even more chloroplasts because that's where more sunlight passes through. Because remember, the epidermis is clear. So more sunlight into these ones at the top and less sunlight to the ones at the bottom. Now, I actually mentioned in the video last night, but we do it later. The ones at the top are long and thin, like my pens, and they're next to each other. Do you know what a palisade fence is? that fence that's made up of those long metal poles with the spikes at the top.
Oh.
Okay, so they're long, thin cells next to each other, and they're tightly packed, and they've got lots of chloroplast so that they can get lots of sunlight. But the ones underneath, palisade means like poles, the ones underneath are rounded. Can you see that?
Yes.
They look like sponges. So it's called spongy parenchyma, and they have less chloroplast because less light goes through. Got it?
Yes, ma'am.
Okay, we're all happy. All right, so that we'll pull together later. That's when we do those pictures that we colour in. I'm just mentioning it now. Okay, so why did I put this here? Because that's a cross-section of a stem. And on the outside, what surrounds the stem?
Epidermis.
Epidermis. And maybe, yeah, you can see the little green things there. Right? Where are they?
Guard
There.
cells.
Guard cells. So green stems will have guard cells, but the epidermis is clear, no chloroplast. But now we need to fill up the stem. So what's all this green tissue and white?
Parenchyma.
Parenchyma. But why are they coloured in the parenchyma near the edge green?
Yes, chloroplast.
It's got chloroplast because sunlight can still go in there. But I think this is a bit too green in the middle. Okay, I think sunlight will maybe only go over here. The dark green here, when we come back, that's parenchyma, like in the celery, making the stem stronger. Right, so we're just talking about the light green going to white. In the middle, the cells actually get quite big. And sometimes, have you noticed if you break off a stem and it's hollow in the middle? No, it's called pith. It's called pith. And the parenchyma cells break down in the middle sometimes. But all these light green ones are parenchyma, they're filling up. Now this is the prettiest tissue. I love it. When you look at it under the microscope, it's really, really pretty. So there's epidermis on the outside. So we could make little cross sections of stems, and I do that. All right. And all this is parenchyma, and maybe there's still parenchyma in the middle, but there's no chloroplast. It's called pith. This we'll type later when we colour in pictures. But all of this is parenchyma, and the parenchyma near the edge would have chloroplast, and maybe not towards the middle, because the sun can't get through. All right. This is the prettiest one. Look at this. What does it look like? I always think it's like bubble wrap. Okay, so each of these, so this would be one cell. And it would have, there you can see a nucleus, vacuole, cytoplasm. Maybe they are chloroplasts, because remember we said in the leaf, there could be chloroplasts in the stem, but in the root, the parenchyma filling up the root, is it going to have chloroplasts? No. Okay, so parenchyma differs. All right, so they got, can you see they've got very thin cell walls? They're not very strong, they're filling up. They're going to store sugars, like an apple. They're going to store starch, like a potato or a carrot that's gotten a bit older. It could be fructose, glucose. Grapes have, what's it called? Fructose. Sugarcane has sucrose, do you remember? Disaccharide. What else? I was going to say lactose, but that's not right, that's more. Okay, so they can store glucose. A lot of fruits contain glucose, fructose, like in grapes, fruit sugar, sucrose, like in sugarcane, maltose, like in barley. And then they make barley into beer, and that's why they call it malt. It's got lots of maltose. All right, so there are thin cell walls. There's cytoplasm. What do you notice, though, between the cells? That's what makes it look like bubble wrap. And they are little rectangles. They are called between the cell air spaces. And sometimes they're big and sometimes they are small. And it's the easiest one to recognize under a microscope. It's really pretty. Oh wait, just on here, let me just try and do this again. My video is not lined up now. Oh, moving it the wrong way, that's why. Okay. All right, so that's the last tissue that we're doing. It's the one that could photosynthesize, like in the leaves or the outer part of stems, because there could be chloroplasts. So if this was a photosynthesizing cell, there would be chloroplasts and the vacuole and all the other organelles. But if it's in the root or the middle of the stem, it's not going to have chloroplasts. But you recognize it by intercellular air spaces. Yeah?
Why do epidermal cells not have chloroplasts? Because they are in the sun most of the time.
Because they're protective. So they're just providing that barrier, also for bacteria and things, and they're covering the outside, but the photosynthesizing tissue is in the inside. It's just the way they've developed. I know, I've also wondered that. So they're there as a protective layer, see-through, or transparent, so that light can go through. It's just the way it is, yeah.
And ma'am, why are there intercellular air spaces?
Because when you feel plants, don't they sometimes, or leaves, they sometimes have a little bit of give, so they've got to be able to move. If they were like this, snap in half.
Oh.
So it allows them to, like when you walk on grass, don't you think, oh, I'm killing it? And they just bounce back.
Yeah.
Because the cells have got some give. Because there are air spaces between many of them.
So it says here intercellular
Okay.
air spaces.
Right, so on the table, okay, so parenchyma. Right, guys, at home you can look at the table. So I've said there, they're loosely packed cells in root stems and leaves. And then next to it, I've said the cells can store water and the food can be in the form of
Oh,
sugar or
glucose.
lots of different sugars and starch. Okay? Can you see why I say it's a story? It ties up with what we did at the beginning of the year. Now we're pulling it all together. So sugars and starch. Okay, hang on. What are those intercellular air spaces? Why are there air spaces? Not just to make the plant spongy, all right? But those air spaces allow for...
Oh, gaseous exchange.
Yes. Okay, because air can go into the stomata, and then it can go into the cells, like CO2 in or O2 out, or the other way around. So those air spaces allow for gaseous exchange. But gases can also just diffuse through cell to cell to cell. The air spaces allow for gaseous exchange. All right. Okay, so I've said the intercellular, large cells with many intercellular air spaces that allow for gaseous exchange. Why? Okay, gaseous exchange. I actually gave you the answer there. Thin cellulose cell walls, so they're not strong. So they're filling up the plant, storing, photosynthesizing. So when we come back, sclerenchyma and parenchyma are going to strengthen the plant. Then some parenchyma contains chloroplasts like stems and leaves, and a green apple, the skin, or the inside of the apple could still be a bit green. And then if it becomes a red apple or a yellow apple, then the chloroplasts become chromoplasts in the cells underneath the skin. Okay? Although the skin has got chromoplasts, if I think about it. So there the skin is different, it's many layered. All right? And then last one, okay? So that's parenchyma. Oh, wait, let's first do this. All right, so you just saw a cross-section there. So what does parenchyma look like from the side? So as botanists, we need to figure out orientation. So if I hold my mitochondrion up and I cut it this way, it's called a longitudinal section. If I cut it that way, you're going to see an oval, it's called a cross-section. Okay? So there's, I don't like that word. I must actually change it. That is a cross-section, or we call it a transverse section, or CS, cross, or the symbol cross, or transverse section. So how many of you cut cucumber at home? Do you ever cut it long?
No.
But sometimes people use a vegetable peeler to make those long strips. So that would be a longitudinal section, so it would be long, looking from the side. But a cross-section when we cut cucumber slices. So you need to be aware of orientation. So what does a parenchyma cell have? It's got thin cell walls. Where's the cell wall here? Thin cellulose cell wall. And then it's got cytoplasm. They're coloured in green because everyone thinks all cytoplasm is green. No, it's not. Only if it's got chloroplast. There's the nucleus, there's the cytoplasm, and there's the vacuole. So they could be long cells from the side, but across, you see them as sort of ovals or hexagons, and there's the air spaces for gaseous exchange. And that's how you recognize them. Very pretty under the microscope. All right.
It says in the air spaces.
Oh, yes.
Also,
Okay, so let's have a look. The large air spaces to make plants buoyant. Is that what you're asking?
yeah.
Okay, that's the next one. Okay, so those are general parenchyma cells. Like in the leaf, if they contain, the next one. If the parenchyma cells here, it's actually not a nice photo. But if the parenchyma cells have got chloroplasts, we can call it chlorenchyma. Do you remember that table at the beginning, that tree diagram?
Oh, yes.
So if they contribute, I don't use that word often though. So if the parenchyma cells have chlorophyll, then chloroplast, then we call it chlorenchyma. These are moss cells. Look at all the chloroplasts inside. And that's what I also put under the microscope. Okay? And last thing, done. Oh, there's another one. Okay, there's the leaf again. So we're going to tie this up later on. So we know there's epidermis, and all the parenchyma in the middle. And yes, it's called palisade and spongy, but we're not going to worry about all these words now. All right, and then the last one, a water plant. Who's got water lilies in a pond? In their houses or gardens, or gardens. So there, these air spaces, look how big they are. Huge. There. So if you cut through a stem of a water lily, or if you even look inside the leaves of a water lily, there's huge air spaces, and all it does is make it buoyant. It floats. Okay, here's a question. Would this water plant have a waxy cuticle covering the epidermis?
Yes.
It's in water. Is it worried about losing water?
No.
Okay, so water plants generally don't have a waxy cuticle because they're in water. They don't have to worry about dehydrating unless the pond dries up. Then they're not going to make it. Okay, so here, these are all the parenchyma cells. There's the epidermis. Here's the epidermis. This is an electron micrograph. And there are all the parenchyma cells in between. Alright, and these are the big air spaces making them buoyant. Okay, guys, I'm finished. Yeah.
What are guard cells in water plants on top of the leaves instead of on the leaves?
Exactly, yeah. So, okay, so if this is a water lily leaf with that funny shape, so now the guard cells would be on the top because then they can exchange gases and they can transpire. If they had guard cells underneath and they opened them up, they would
Flood.
yeah, they drown. So in a water plant, okay, that's just for interest. In a water plant, the guard cells are actually on top to allow for gases exchange.
Learn something new every day.
See, I told you botany was fun.
It's actually really interesting.
Now, Dr. de Jong, she did it 1 year, she said, never again. But it's just because I did it for 3 years, and I just enjoy it. And I love all my little models, and I've made things. So what have we done? We've done meristematic, we've done epidermis, and parenchyma, and I've mentioned that the parenchyma is chloroplast. Some people call it chlorenchyma.
But we don't need to know that.
So you're aware of it, aren't you? So you know what it means. I don't often use that term. Okay, that's it.
Wow.
Ma'am, what worksheets are we marking tomorrow?
All right, so what I've said, people at home, that photo worksheet that I gave you.
This one.
Yes.
We're marking now.
No, we haven't done it yet. So the photo worksheet, plants, tissues. I think the one that's uploaded on Google Classroom has the animal tissues at the end. I actually thought I took them all. So all the only ones that you can do are A. And A's got 2 photos next to each other. Keep losing my little cloth. Okay, let's use this. Okay, so the photos that you can do on that worksheet, it's A, there's 2 of them. D's from yesterday, the one that looks like that. Oh wait, we can also do here, this one, and it's got this funny squiggly arrow going down. You can do that one. So you can label and name those photos. And then on the next page, page 2, we've done E and F. Oh wait, I forgot about C. This is C. These 2 here are C. So it's A at the top, C down the side. They're the same, different versions. D we did yesterday, and E and F on the back of the page.
Okay. But ma'am, for letter A, there's 2 lines.
Yeah, you must just look, I know this is hard, because I can see it straight away, but I've said that they must try it in pencil. So on the lines underneath, wherever it says A line, B line, whatever, that's where you name the tissue. Like, is it parenchyma, root epidermis, leaf epidermis.
Oh.
That's all we've done, and meristematic. But then the arrows is to try and get an idea of what are the parts. So it might be better to go and look at the photo, the color worksheet on Google Classroom. Let me see if I can pull it up. Okay, let's just see. I think it's lesson 2.
But now we will mark this.
Okay. We'll spend time tomorrow. So this one here. So you're just pretending to be a botanist now, just by trying to recognize. I mean, do you think epidermal cells are this funny green color? This
No.
bluey green. Why do they look like that?
Because of the dye.
The dye, the stain that they've added. But here, this is an electron microscope picture. So it just depends on how they take the photo and what kind of color or stain they add to them. Okay, guys at home? I don't know who was there. I just see one little, what's it called?
Icon.
Icon. Okay. All right. So you can do the photo worksheet and look at the photo worksheet. It's on Google Classroom, lesson 2, so that you can see it in color, because I know the black and white isn't great. Okay. And tomorrow we will go through it. All right.
Don't we have a
Wait till it was A, C, D, and E, and F.
Yeah.
Okay.
I don't want to move them all around because then it's going to, that's a lot. Oh, I must stop the video now. So then I'll upload